Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer released in 1991. Now that we can parse graphics and the levels, we can start working on the actual game. In this episode we will implement the heartbeat of the game loop. A game loop is a never-ending loop that processes input, updates the state of the game based on those inputs, and then renders the graphics for the resulting state to the screen. This is used for the main gameplay, but this also works the same when navigating the menus. Now, the original game used a base speed of 16 frames per second. While not very much by today's standards, we will start by creating a game loop that matches the speed. Once the loop is in place, we will call a render function that will draw the visible part of the level to the screen. Now, there are multiple ways to implement a game loop, but since what we are doing is fairly simple and it's an old game, a game loop with a fixed time step is good enough for us. Alright, so let's start with the game loop. Let's loop forever here, and inside of this loop we'll update, we'll handle input, and we'll render the scene. Alright, so as I said in the introduction, the speed of the game, the original game, is 16 frames per second. So we need to translate that to a fixed time step. So I guess we'll just call it time step here. And we'll assume 1 second. And we'll do it in nanos, because that is the highest resolution that we can do here with Java. So let's keep track of the last time we updated. And let's take the current time in each iteration of this loop. And let's compare the two. So subtract, and if it's larger than the time step, then we need to do our stuff. And to truly have a fixed time step, we need to update the last update time with our time step here. And now, to prevent this loop from running as fast as it possibly can, we'll sleep it here. And you could argue that it would make sense to sleep here for time step milliseconds, but Java's sleep timer is notoriously inaccurate, so we'll just sleep for 1 millisecond and then repeat the loop. Alright, so let's make an instance of our class and let's loop. And let's run it. Alright, so nothing is happening, obviously, because we're just looping without actually doing anything. So let's change that. Oh, we're still writing out all the maps here from last episode. Let's remove that code, we don't need it anymore. Let's assign this variable, and let's also assign the resource loader. Let's move the stuff out of the static void main. Let's just make a default constructor. And let's also make a separate init function. And let's make an instance of Duke Nukem. Let's init and let's instantly loop. And then the IO exception is no longer relevant here. Okay, so we have our game loop here. And let us now create the actual graphics component. So we can open up a window here. So in Java, opening up a window is simply done by instantiating a JFrame. And let's exit the application once you exit the frame. So if you press the X button, it will exit the program. Let's center it on screen. And let's set it to visible. Alright, so if we run it now, then we get this window here, but there's nothing in it just yet, but we'll change that right now. Because now that the game loop is in place, we can start rendering some stuff. So let's make our graphics component. And in Java, you can paint graphics to the canvas. So we'll just extend the canvas. And the original game had a resolution of 320 by 200. So that is also what we'll go with. So we can set the preferred size of this component. And we can, for now, use the paint method here. Let's set the color to black. And let's paint the entire background black. Then to use the graphics, we'll assign it here. And we'll add it to the frame. And we'll pack the frame, meaning resize it to match all the, to fit all the components added to it. So that's why we set the preferred size here to width and height. And that tells pack to use the preferred size and to resize the screen. So let's take a look. All right, so here we have the screen and we've painted it black. So it's a bit small. Let's make it slightly larger. Let's also make that. Let's make it 3 times as big. Okay. So now we can make a render method that we'll call from this game loop. So we can say gfx.render. Okay, so let's talk about double buffering. When you draw graphics to the screen in a loop every, multiple times per second, if you do that straight to the screen, you'll see all kinds of weird artifacts and weird glitches, blinking stuff, screen tearing. And the way that we solve this is by drawing to a back buffer. And then once every loop, draw the entire back buffer in one go to the screen. And this minimizes the visual artifacts I just discussed, like the flickering and all this kind of stuff. So, oh, I wasn't using the scale here. So let's get into it. So let's create a back buffer. And in our case, it's just going to be an image that fits our resolution. And we can remove this one here. And we can say this render function gets the graphics of the buffer. And let's assign it. Let's set the color to black. And let's fill the rect to clear everything. And in order to get the buffer displayed to the screen, the canvas has something that's called a buffer strategy. Now, if the strategy is not there yet, we need to create it. We'll just give it 3 buffers. And if it is there, we can get the graphics from the buffer. We can draw the image that we created in the back buffer to the screen. And we'll take in the width and the height of the image based on the width and the height of the canvas so that it will scale appropriately to the window size. And we need to dispose of the graphics. Okay. So this should flip. Oh, I forgot. The strategy needs to show the buffer. All right, so once we're done rendering, we need to flip the buffer to the screen. Let's render the level. Now the graphics needs to have a reference to the level, but it also needs to have the graphics. So let's start with that. So let's give the graphics a instance to the resource loader. And let's, for now, this is the wrong list. We need to have a Java util list. There we go. And then let's take in the tile set loading here. And let's just do that in the constructor for now. We'll probably create an init method for this class as well. Okay, so now we have all the tiles needed to render the level. And yeah, let's just reuse the render code that we made earlier. So here we can just draw, here we can just draw to the graphics of the back buffer. But now instead of going across the entire map, we need to go across the visible portion of the map. So that was 13 columns by 10 rows. That is visible. But we need to scroll around in the level, so we also probably need an X and Y coordinate for the, well, for the camera, if you will. So let's make a new object. We'll call it game state, which will contain the level, and which will contain, I'll just call it camera X and camera Y. Let's create a constructor, and let's get some getters. And a setter method to move the camera to a new position, or I guess we'll use some deltas here. So we can say camera X increment with the delta, and the same goes with camera Y. And we'll assume we don't have to set, it starts at 0, so we don't have to explicitly pass it in the game state, but we'll assign it anyway to be complete. Okay, so now our render function can take in this game state. And we can say that we go across 10 rows, 13 columns. And that means that the actual row needs to be offset by the camera Y position divided by 16. And the same goes for the column with the X divided by 16. Game state.get level. Okay. All right, so this will draw the level from the camera's point of view. So now all we have to do is actually create the game state. And pass in the loader here. Let's create the game state based on level 1. And I'm guessing it would be nice to do that in the initialization function rather than the constructor. And here all we have to do is pass in the game state. Okay, let's run it. Okay, we're not seeing anything, probably because the top left part of the level has no content. We should move the camera to the correct position where we do see some stuff. And we can do that inside of the update function, where for now we'll automatically move the camera around. So let's make a private void update here. And then let's say GameState.moveCamera2, and let's move it half a cell at a time. Let's rename this function to move camera. And if we now run the game again, we should hopefully see something moving. Yeah, and there we go. We're just flying across the level. So that's looking pretty good. And there we went out of bounds of the level, so we'll have to fix that later. But for now, this is looking pretty good. So let's tie up some loose ends. Let's first swap some stuff here. So let's call a switch level to the game state function, to the game state object. Now the starting position for the camera will depend on the starting position of the player inside of the level, but we'll have to do that in a future episode. So this is looking decent. So in the constructor, we can then instantiate the game state as an empty object. And then rather than doing a new game state in the initialization function, we can just call switch level here. And we should also give the GFX class a chance to initialize the tile sets in a separate function here. So that would require us to assign the resource loader. So we'll just assign it here. And then we'll assign the tile set in the init function. And then this compile error should be gone, which it is. So in the next episode, we'll fix the scrolling, where we can do a bit more smooth scrolling. And we'll also create an input handler so that we can scroll around in the level ourselves. But for now, I want to thank you very much for joining me. If you have any questions, feel free to put them in the comments below. And see you next time. Bye-bye.